side. But it is possible that it can also be done from the right-hand side. So I might show you both ways. Okay? Please be aware that this part that you are doing, your grade 11 proof of identities, is very, very important. Okay? When you write metric, there will always be one question on proof of identities. And proof of identities are not taught in metric, they are taught in this grade. But they will be tested in metric. Okay? So I'm going to choose the left-hand side. So my left-hand side, if I want to eliminate the denominator, okay, first thing, I'm going to convert cos squared to sine squared using this identity here. So I'll make cos the subject so that I can write it as 1 minus sine squared x divided by 1 plus sine x. Okay? Why am I doing that? Okay, well, someone might be asking, why is he converting cos squared x to 1 minus sine squared x? I know that this expression here, from your algebra, factorization, what do you call it? Difference of what? 2 squares. It's a difference of 2 squares. We are intrigued. Okay? One of the reasons why you are taught difference of 2 squares in grade 8 and 9, it was to prepare you for trigonometry, because you need that concept. You need that concept. All the concepts on factorization. Factorization by a common factor, factorization by dots, factorization of trinomials, factorization, okay, the difference in sum of 2 cubes, we don't really need it in trig, but you might encounter it. Factorization by grouping, you need those concepts in trig, but you will not be told factorize here. You must see it, that okay, here I need what? To factorize. So this can be written, it's a difference of 2 squares. That's how I'm likely to eliminate that 1 plus sine x. Okay? Now, once I get to this point now, the next thing, okay, in this case, if I factorize this, I might end up complicating the question. Okay, if I factorize it as it is. If I factorize this, I'll get 1 plus sine x times 1 minus sine x. So the 1 plus sine x in the denominator and one of the factors of that will end up cancelling out. And when that happens, I won't be able to get what's on the right-hand side. So it means I have to redo that numerator in a different way. Okay? I have to redo the numerator in a what? Different way. Okay, so to do that, I can, yes? I don't want to factorize, to simplify both sides, no. I want to simplify only one side. So the strategy is to eliminate this 1 plus sine x. That's the strategy. Okay? So what I'm going to do now is I'm going to use a technique which is a little bit complex, but it's a mathematical manipulation which is correct. So I'm going to change that. For this question, if you convert cos squared x to 1 minus sine squared x, you have problems. Okay? So what I'm going to do is I'm going to multiply this fraction by 1. But the way that I do it, I introduce the conjugate of that. The conjugate of 1 plus sine x, it's what? 1 minus sine x. So it means I can write this as cos squared x, right? Cos squared x over 1 plus sine x. Then I can multiply this by 1 minus sine x over 1 minus sine x. Please be aware that this is equal to what? To 1. Okay? That's equal to 1. Alright? Then, from there, from here now, I'll end up getting cos squared x minus sine, so that will be sine x times cos squared x. Okay? This is all over. All over. Now, if I multiply those two, I'll get 1 minus sine squared x. Do you see that? Huh? Your factorization. Okay? This times that will give me a difference of 2 squares. Okay. The numerator, I talk about this. Okay, let me just write it nicely. This is very interesting, by the way. So, okay, what I did here was in order to carry on to simplify the left-hand side to get the right-hand side, you need a mathematical manipulation. So just multiply the fraction on the left by 1. But to do that, you need to multiply it by a fraction which is the numerator, which is equal to the conjugate of the denominator of the fraction. Why do we do that? Because we know that if you multiply 1 plus sine x by 1 minus sine x, we'll create a difference of 2 squares, which will be 1 minus what? Sine squared x. Okay? Alright? Then, if I multiply cos squared x, now let me use a different color. If I multiply cos squared x by 1, I will get cos squared x. Then, cos squared x by sine x, I can write it as sine x times cos squared x, or you can write it as cos squared x times sine x. It's the same. Okay? Alright? Are we all okay now? Right? Now, when you are doing proofs, use common sense. Okay? You must see whether what you are doing is getting you to the answer or not. You must see it from a distance. Okay? I know that this is going to be equal to, I'm already smiling. This is cos squared x. You're laughing. I am already smiling. Right? So you get that. Then you get cos squared x. Okay? Now your knowledge of fractions, you see that the cos squared x is a common what? Do you see that it's a common denominator? Do you see that? So you can split your numerators and write them under the same what? Denominator. That's how you create this one here. Okay? That method, you see, I'm just going to share this with you. The method that you're talking about, of simplifying the left-hand side, then you also simplify the right-hand side until you get something which is the same on both sides. I would consider that as a desperate method. Yes. Yes. You know why? Listen. Simplify the left-hand side only until you get the right-hand side. Simplify the right-hand side only until you get what? The left-hand side. I don't like that method. Okay? I'm serious. I don't like it. Don't like it. Okay, so let's move on. Okay, just to be a bit harsh. It's a method where the person realizes that no, they can't carry on. Then they want to make a plan to the what? To the right-hand side. And get something which is equivalent to the left-hand side or vice versa. Now we are going to simplify that left-hand side until we get the what? The right-hand side. Okay? So from here, you get cos squared x divided by cos squared x minus, I'm smiling already, sine x times cos squared x over cos squared x. Right? Now you might be wondering how is he gonna create tan? Well, it's very simple. Right? This is 1. So already I'm smiling because I've got this 1. I've got my minus, which is here. My minus. Then, now, from there now, I'll say sine x times cos x times cos x all over cos x times what? Cos x. Fortunately, these two will give me my tan. Okay? Alright? And then these two will cancel each other out. Okay? So the final answer will be 1 minus tan x times cos x. But you have to know your fractions very well. Okay? You have to know your fractions very, very well. So, I'm smiling now. So I'll say therefore, left-hand side is indeed equal to the right-hand side. I simplified the left-hand side without touching the right-hand side. Okay? Now we can do the reverse as well. We can simplify the right-hand side without touching the left-hand side. You see, trig identities, sometimes they are not that easy. That's why people end up going via that route now. Because the person simplifies, they see they can't get the right-hand side. Maybe let me simplify the right-hand side to get what I have now. Okay, it happens. I saw it right now in the math test, grade 12. Okay, but I don't like that method. You must know your stuff to a point where you simplify the left-hand side only and get the right-hand side, or the right-hand side only and get the left-hand side. Know your stuff. Okay, so let's do the reverse. Yes. Huh? You want me to talk about that? Okay. You see, the temptation for this question will be what I wrote at the beginning, to convert cos squared x to 1 minus sine squared x. If you do that, you complicate things. Okay? Well, it could be possible that we can carry on, but it will complicate things. So the best way is to do a mathematical manipulation whereby you multiply this fraction by 1, but not directly. You multiply it by a fraction which is a numerator, which has got which is actually a conjugate of the denominator of this fraction. By conjugate, we are saying instead of having a plus here, we have a what? A minus. So 1 minus sine x divided by 1 minus sine x is equal to 1. Okay? The good thing about that is if I multiply this denominator by that, I'll end up getting my difference of 2 squares. And this difference of 2 squares is actually equal to cos squared x. Alright? Then you multiply this numerator by this one and that one. Then you create that. From there, you convert 1 minus sine squared x to cos squared x. Now we have a common what? Denominator. Since we are here, we have got subtraction in the numerator, we have two terms. We can write them under the same denominator separately in order to create this one here. So, I wrote it like that. So, I got my 1. Then there's this minus. The next thing is to create tan. Tan is equal to sine over what? Cos. So you work in a very smart way. You break the denominator up into those two cos x's. Then one of the cos x's, if it combines with the sine x, you get your tan. Then these two will cancel out. You're left with your cos x. and then you are done. Okay? Right? So let's do the method 2.
What happened to that cosine x?
Which one?
The sine x, cosine x. What happened to the one on the numerator?
What happens when the numerator?
Yeah, what happened to cosine?
There are two, remember.
Yeah.
This one here combines with that to form the tan x. Because of multiplication, I hope you see that there's multiplication where there's multiplication. So they can combine to form the tan. Do you all see that?
Yes.
Okay? So method 2 now, let's simplify the right hand side. So, right hand side is equal to 1 minus tan x times cos x. Okay? Alright? Now we are going backwards. We are going from right to what? To left. Throughout. We are not looking at, we are not going to simplify the left hand side along the way. No. Right? So, that will be equal to 1 minus sine x times cos x over cos x. Okay? Now, the problem comes now. This is where the problem comes. If I want to start with the right hand side, in order to get the left hand side, I need to end up getting this cos squared x. Also, for me to get this 1 plus sine x, it means I'm supposed to get somehow 1 minus sine squared x. And to get this 1 minus sine squared x, I need to first have what? Cos squared x. So I'm going to do another mathematical manipulation. Okay? The mathematical manipulation, it's so cool because all you have to do is multiply this by cos x over cos x. Because I know that this 1 plus sine x, it comes from 1 minus sine squared x. And the 1 minus sine squared x comes from cos squared x. So the only way that I can create the cos squared x is to do what I just did, this part. This is the key. And that's the one which causes people to go via that route. Because they are not aware of that. Right? Okay, so let's carry on. So this will be 1 minus sine x times cos squared x over cos squared x. Then our denominator there is a 1. So our LCD is cos squared x. So this will be cos squared x minus sine x times cos squared x all over cos squared x. The concept of the LCD is so important. Okay, just to tell you something. When you are doing trigonometry, if you can't find the LCD, you are going to have problems starting with the proof of identities. Okay, from here now, I'm smiling already. Okay? Yes, I'm smiling. I'll convert the denominator. So I'll write here cos squared x. I can take out my common factor. 1 minus sine x. Factorization, you see that? Right? Then convert the cos squared x to 1 minus sine squared x. I'm smiling. Right? Then the denominator, it's a difference of 2 squares. So this will be cos squared x times 1 minus sine x all over 1 plus sine x times 1 minus sine x. I'm smiling. Okay. And my heartbeat is normal. Those two cancel out. You see that? Huh? Yes. Then we get, don't worry, I'll come there. Don't worry. So we get cos squared x over 1 plus sine x. Therefore, it's true that the left-hand side is equal to the right-hand side. You see that I never touched the other side. Everything I did was only on one side. Okay. You're following? Huh? You're following? Right. So number 5, I'll choose the left-hand side. 1 over 1 minus cos theta plus 1 over 1 plus cos theta. So, what's the LCD? Yeah. But what is the name given to the product of these two? Difference of what? 2 squares. So, that will become 1 plus cos theta plus 1 minus cos theta. This is all over 1 minus cos squared theta. Please, you should know, if you do a lot of practice, that to get this sine squared theta, you need to create 1 minus cos squared theta. Okay, always. Right? Then 1 plus 1, that's 2. Cos theta minus cos theta, that will be 0. Then you convert that to sine squared theta. Therefore, the left-hand side is equal to the right-hand side. Okay? This one, finding the LCD will be 1 mark. Okay? This one could probably maybe 3 marks. It's not that complicated. Right? Your homework is to simplify the right-hand side to get the left-hand side. Okay, that's first question of your homework. Then, the second question, please take note of that. I'm going to check it tomorrow. You must simplify for question 5. This is on exercise 6, page 123. You simplify the right-hand side to get the left-hand side. Okay? Then you get more complex. You also do B3. Okay, B3 and B8. Please take note of that. B3 and B8. First, simplify the right-hand side for question 5 to get the left-hand side. Okay, completely. You work with the right-hand side until you get the page 123 and 124. Sorry, 122 and 124. Wait, it's 123. All right, I'm going to repeat what I said. You simplify the right-hand side for number 5 to get the left-hand side. Then you do B3 and then you do B8.